This is Ham College, episode 22 for October 31st, 2016. Ham College is brought to you by ICOM. Holiday season is here, and ICOM has the radios they want. And by hamstudy.org, a great way to study for your next exam. Hi, and welcome to another episode of Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And it never gets old, I swear.
Apparently not. People keep coming back. We keep doing it.
Yeah. Well, it's the special Halloween episode. We both have on our costumes tonight.
Yeah, I'm dressed like a Radio Shack employee.
And I'm dressed like a fisherman.
Kind of wore out.
Yeah.
That's what the Radio Shack employees look like, right?
Well, that's... yeah, kind of. It's probably what they feel like these days. Well, what are we going to talk about? I guess the first thing is the chat room. You know, we have a chat room going on whenever we're taping something live. And you can tape live.
You can.
Yeah, but you can't do it with one of these digital video cameras because they don't have tape in them.
Yeah.
So we do the next best thing and simulate it in memory.
Yeah, virtual tape.
Yeah. But we've got a chat room going whenever we're streaming live. And on this show, it's particularly useful.
It is.
And that is because of why?
Because there's a lot of hijinks going on in that chat room.
Well,
for the most part.
And they are feeding us the answers.
Yeah. So they go in there and they try to answer the questions at the same time.
Yeah.
Most of the time they're right. So.
Yep, most of the time they are.
Yeah. So a lot of smart people out there.
It just kind of verifies us.
Yeah. You see the URL to the chat room. There's also one on YouTube, and if you're in there, leave that one and come join us over here. We cannot watch that one from where we're taping, so we have to use this other one. It's just too much bandwidth to try to stream that and see the
well, we don't have enough iPads and all to.
Yep. So come join us over at the URL that you see on your screen.
Yep. Okay. Well, I guess what do we want to talk about next, Tommy? What did we talk about last month? Do you even remember?
Yeah, it was very symbolic.
Oh, it was. Yeah.
It was. So we talked about electronic symbols, components.
We did.
We did. I got a funny feeling we're going to do some more of that.
There could be some on this episode here.
It could be. That's when I wore my Radio Shack t-shirt for a little help. It's like my thinking cap.
You know, we in the first probably 21 episodes or so of this show, maybe just the first 20, I lose count, but we had questions in there a lot about different things like some of the rules and the regulations and
some operating
things like
things.
That. We're whittling our way on down to the bottom of the question pool now. And most of the ones that are remaining are all going to be on electronics and theory and that type of stuff. So we got a lot of that tonight.
Yeah. And that's fun stuff too.
That's fun stuff. Yeah.
And it's actually going to be a good refresher for me too, because I don't get to tinker around with that stuff very much. I went through it when I got my license, obviously, and I play around some, but so it'll be good to go back to some of that stuff.
Yeah.
You may hear a buzzer or two tonight.
You could. I doubt you will. You know, I know probably your favorite section of the exams were when we were doing
You gotta love that, the Big Bear aspirin.
Yep, and the big pie.
Yeah.
But I know, you know, how much you enjoyed that. So tonight, I've got some schematics printed out on a card, and
awesome.
And we're going to be talking about them, and we'll look at them. We'll talk about how those schematics work.
Okay.
After we get a little further into it. I guess without any further ado, why don't we get right on into the questions tonight?
Okay.
So our first one here, why don't you read the first one?
Which of the following is used together with an inductor to make a tuned circuit? A. Resistor.
B, a Zener diode,
C. Potentiometer.
or D, a capacitor? And Tommy, I really should have read this one because, we were talking about how you might miss some of them tonight, and this would be the one I think out of all of them that, well, I don't think you'll miss it, but you could. So why don't you answer this one, even though you read it?
Okay. Well, I think I know this one.
I think you do too.
Yeah. So, and I don't really know how to reason it out, but I'll be honest with you, I don't even know what tuned circuit. I don't know the technical definition of that. So maybe you can go into that after the question.
Joe, I can tell you right now, it's right the opposite of an untuned circuit.
Oh, okay.
Does that clear it up?
Yeah, it sounds a lot better to me.
It builds your confidence right
Yeah.
up.
So I do remember this from a while back about it. Capacitor is the answer. D, capacitor.
Well, that's what they're all saying in the chat room. And, if you ask me, there it is. You're right.
There. Okay.
It is capacitor.
Now tell me why it's a capacitor.
Why is it a capacitor? Well,
Professor
first
Thomas.
let's talk about, what a tuned circuit is.
Okay.
A tuned circuit,
You can tune a circuit, but you can't tune a fish.
yeah, maybe.
Is that a song?
Yeah, well, that's the name of an album, I think.
Okay, it's close enough.
Yeah. But remember the old graphic equalizers that you had for your stereo, and there's still some around, where you got all these little bands on there and they've got frequencies written up under them.
Mm-hmm.
And you can adjust your bass or your treble or, whatever
Yeah.
you want with
EQ.
that. Those are little tuned circuits.
Okay.
So each one affects a certain frequency.
Okay.
And that's basically what we're talking about. When you spin the VFO knob or change frequency on your receiver or transmitter, that's basically, well, today it's digital, but essentially it's tuned circuits. You were causing a circuit to respond to a particular frequency. Well, like a filter. Filters are tuned to particular frequencies.
Mm-hmm.
A resistor is really not tuned to any particular frequency. It's the same whether it's DC or AC and virtually any frequency. A Zener diode, basically the same thing. It's not frequency sensitive. A potentiometer is not either. That's just a variable resistor. But a capacitor does respond differently, different values at different frequencies.
Yeah.
And inductor is the same way. So if you put those two together, an inductor and a capacitor, you can make a tuned circuit for a particular frequency depending on how you wire them together. You can make it emphasize certain frequencies, or you can make it cut certain frequencies.
Yeah, interesting.
So
That's something I think I'd like to read up on a little bit more.
I think you should. Yeah.
Yeah.
You should do
Pretty
some
neat.
experimenting.
Yeah.
Yeah.
Maybe so.
I thought about it tonight, but I got to thinking, well,
No, it would have been good.
yeah, it would have. It'd have been, well,
I love
didn't.
all this stuff, but I just really don't have time to tinker around with it very much. So I just
all right, let's go on to the next one here. And why don't you read this one again?
wow.
And I'll answer it.
Okay. What is a simple? Oh, hold on just a minute. I think we just gave the answer. What is a simple resonant or tuned circuit? A, an inductor and a capacitor connected in series or parallel to form a filter.
B, a type of voltage regulator.
C, a resistor circuit used for reducing standing wave ratio.
Or D, a circuit designed to provide high fidelity audio. Well, if you were paying attention, I think you might know the answer to this one.
Yep.
And everyone over in the chat room looks like they're saying it's A.
They must have been paying attention too.
I think probably they were. Yep. Although I did talk about your graphic equalizer, it's nothing to do with high fidelity audio. A simple resonant or tuned circuit is going to be A, an inductor and a capacitor connected in series or parallel to form a filter. Would you agree with me?
I would concur.
There we go. We forgot to give you a fist bump a while ago. Yeah, we should have. You'll get the next one then.
All right.
All right, so let's move on to the next question here. I don't think we really need to explain this one since we just did.
Yeah.
Tommy, what is component 1 and figure T1 up above? A resistor.
B, a transistor.
C, a battery.
Or D, a connector. I don't know how to tell you how to reason it out, but the answer is A, it's a resistor.
Yep.
And the reason it's a resistor is because I remember that that's the symbol for a resistor.
Okay.
So some of these electronic ones, you're not going to be able to reason very many of those out. It's going to be basically looking at the diagrams and memorizing them and learning them.
Well, let's go ahead and give you your fist
Okay,
bump.
I'll take that.
You got that. So, yeah, it's a resistor, and that's because the symbol that's up under the 1 there is the symbol for a resistor.
It's a good reason.
Works for me.
Yeah.
We'll come back in.
It's pretty hard to argue with that.
Yeah. We'll come back in a few minutes and talk about that circuit and how it actually works
Okay.
on a basic level. So let's move on to the next question. We're going to stay with the same diagram there.
What is component 2 in figure T1? A, resistor.
B, a transistor.
C, an indicator lamp.
Or D, a connector. Well, I see a resistor and a transistor and an indicator lamp and a connector in there, but the one that's got a tube beside it, that's a transistor. That's what they're saying over in the chat room too, and I'm in good company. We all got it right.
All right. A lot of smart people in there.
Yep, and it's an NPN transistor, by the way. That's what Ralph was saying, and yep, Ralph, you're right about that. I think we can come up with another question and keep this same diagram, Tommy.
Let's do it. Might as well get a lot of use out of it.
Yep. What is component 3 in figure T1? A, a resistor.
B, a transistor.
C, a lamp.
Or D, a ground symbol. Okay, so we know it's not A resistor because we just did that. We know it's not B, a transistor, because we just did that. So the next thing in series, I know that's not a ground symbol either. It's a lamp. C.
C is a lamp. Yeah, I'm not, and I'll agree with you. It's going to be a lamp, and that's what everyone is saying. And you're correct, it's a lamp. But your reasoning there is not going to work if you take an exam, because you're not going to have. No, it's not going to work.
But we just did that. But
yeah.
But it's a lamp because it's a lamp.
Well, that's a symbol for a lamp.
Yeah.
That is one. I'll say this. That is one symbol for a lamp. There's actually another symbol for a lamp that I'm more used to seeing.
Yeah, I don't know that I've seen that one before.
That one is a little different, isn't it?
But I know it's not a ground symbol because I see one of those, and I know it's not a transistor and a resistor because I see one of those. I mean, it looks like a light bulb. So.
Yep.
What is component 4 in figure T1? A, a resistor.
B, a transistor.
C, a battery.
Or D, a ground symbol. Well, I just happen to know that's the symbol for a battery.
That looks like a battery.
Well, it doesn't look like one, but that's what the symbol stands for to me.
Yeah.
Yeah, that's what we got over in the chat room. So I think we're just going to have to go with that. It's a battery.
It's going to have to, yeah.
That's the symbol for a battery.
Can't argue with it.
Yep. So there you go. And I think we can even get one more question out of here, Tommy.
Can we do it? How many is that? Like 6 questions out of it?
5.
5.
Close.
Seems like 6.
Yep. What is the function of component 2 in figure T1? A, it gives off light when current flows through it.
B, supply electrical energy.
C, control the flow of current.
Or D, convert electrical energy into radio waves. Okay, this is going to be pretty easy because I wish we had a transistor to show, a real one.
Well, I've got a whole drawer of them, but they're over there.
Well, most of them are just a little black round, a little black plastic cylinder looking thing with a flat side on it.
Okay.
The ones that I'm used to seeing.
The ones that are in that kind of package, yeah.
The ones that I'm used to seeing. So,
okay.
But they do not give off light.
Okay, I'll agree with that.
So that's why I wanted to show.
Yeah.
Okay, supply electrical energy. I don't know. It's not a supply.
It's not a battery.
Control the flow of current. Yeah, that's probably it. But let's look at the other option. Convert electrical energy into radio waves. No, it does not do that. C is my final answer.
So you're saying it's C.
So I'm saying it's C.
Well, by the way, I watched Dumber and Dumber last week. I happened to catch it.
I watch it pretty much every week.
Do you?
Yeah. It's a classic.
Yep. C, control the flow of current.
Control the flow of current.
And that's what everyone was saying over in the chat room. You know, C is a popular answer tonight, Tommy. As a matter of fact, I think it's the most popular answer we've had so far.
It's like John Boy and Billy. You ever listen to that?
No,
they have
I
that
hadn't
quiz
in a
in the
while.
morning, and the answers always take C.
Oh, really?
Yeah.
Okay. Well, how can you go wrong with that?
You can't.
Well, why don't we talk a little bit about that circuit? You know, I said all those components were in there. There's your connector right there.
Mm-hmm.
Those two things there. The other side of that connector would look like that.
Okay.
There is a ground symbol. That's
Yeah.
that's a chassis ground symbol. You know, there's two different kinds. Well, more than two different kinds of ground symbols you could have. You could also have one that looked like that.
Yes, I'm familiar with that one.
You could also have one that looked like that.
Mm-hmm.
But they'll use this one here.
Yep.
All right. This, of course, we said was a resistor.
Yep.
And we said that was a transistor. And Ralph told us it was an NPN transistor. And you know how you can quickly determine if that's an NPN or a PNP?
What does NPN stand for?
Negative, positive, and negative.
Okay.
But there's a little saying you can use to help you remember, you know, because a PNP transistor is going to have that arrow pointed in the opposite direction. So the way you remember it, NPN, just think of never points in.
Okay.
And that means the arrow's pointing out.
Okay.
So that's how you can
Well,
remember
that's a good trick.
NPN. Yeah. And we said this was a light bulb, or you said it was. And,
a lamp.
And you were right about that, a lamp. This is another way that you might see a lamp, you know, in a schematic symbol right there. And this, of course, is a battery. And, you know, the long line, short line, long line, short line. That's, you know, that's just a universal symbol for a battery. Now, what does this circuit do here? Well, we can see the lamp is there, and it's got a battery connected to one side. The other side of that battery is connected to ground.
Mm-hmm.
And then the other side of the lamp here would really need to be connected back to the other side of the battery, you know, to make a complete circuit. The current won't flow unless you've got a complete circuit, but it's going through this transistor, which down here on the emitter you can see it's got a ground. That's the collector, by the way, and that's the base. All right, over here we've got an input drawn. They don't say what you're putting in, but I'm going to tell you you're putting a voltage in there. And basically this transistor is acting like a switch. So whenever you put a little voltage in here, it's going to cause this transistor to conduct, and it's going to allow the flow of energy through it to get to that light bulb. So it's going to turn on the light bulb. Whenever you put a voltage here, the light bulb's going to come on. It's a simple transistor switch.
Cool. Very interesting.
Yep. You could put a blinking voltage on there, and then what would you have, Tommy?
A blinking light.
Yeah, there you
I
go.
About to move that again. I thought you were going to come up with some kind of joke.
No, that was the best I could come up with.
That was it, huh?
On such short notice.
Yeah.
Well, I tell you what, I need to load up a few more questions here because we went through those right quick like.
We did.
Yeah, but while I do that, we've got a little message here from another way to study for your ham exam that's real helpful. And then we've got some nice little tips for you at the end of that.
Cool.
So let's go watch that. Are you new to the ham world or an existing amateur operator who wants to take your license to the next level? Study for your radio license exam at hamstudy.org. Hamstudy.org is a free online learning tool powered by ICOM. It was created by Richard Bateman, KD7BBC, Michael Stufflebean, KV9G, and Rich Porter, KK6GKE, and it uses a modern web design to enhance the experience of studying for your technician, general, and amateur extra exams. Since 2013, hamstudy.org has helped new and existing hams to familiarize themselves with the question pools, use stats-based flashcards to focus on material they need to learn, and take practice exams to gauge progress. Visit hamstudy.org on your desktop computer or mobile device. Register for a free account at hamstudy.org to access personalized study history and other site features. Prepare for an exam in an intuitive and comprehensive manner. Check out hamstudy.org, powered by ICOM, for free learning tools. Good luck on your next exam. I don't know who answered the last question there. I think it was you.
Okay. What is component 6 in figure T2?
A resistor.
B, a capacitor.
C, a regulator IC.
Or D, a transistor?
That is, Tommy, that's the symbol for a capacitor.
Yep.
That's what I'm going to say, and that's...
I got a funny feeling you're probably right.
Yep. B, capacitor. That's what they're saying over in the chat room, and how could I go wrong?
Oh, you cheated and you looked at the chat room.
Well, I already thought it was a capacitor before I looked. There we go. It's capacitor.
All right.
I think we
you
can...
want a fist bump for that one?
I already had
You
a
gonna
fist
pass?
bump tonight.
Okay.
I'm kind of full.
Okay.
All right, so I think we can get another question out of this. Like this one right here. What is component 8 in figure T2? A resistor.
B, an inductor.
C, a regulator IC.
Or D, a light emitting diode. Okay.
Component 8.
I know that arrow pointing to the line like that is a diode.
Yep.
And I see the two little lines coming out of it with arrows, so I'm going to have to guess that that's a light emitting diode. So my answer is D.
It's D. Yep, that's what they're all saying over in the chat room. And you are correct, sir. A light emitting diode.
Nailed it again. You may not get to do that buzzer this time after all.
I may not, man. I've been hitting you with my best shots.
Oh, yeah?
Yep.
What is component 9 in figure T2? A, variable capacitor.
B, a variable inductor.
C, variable resistor.
Or D, a variable transformer. Component 9, let me find 9. Okay. That looks like a resistor to me, but it's got that little arrow kind of tapped in the middle of it there, which tells me that it's variable or adjustable. So I'm going to say that it's C, a variable resistor. Mike says it's a rheostat, which technically he is correct. And Don says it's a potentiometer. But both of those are variable resistors.
All right, you nailed it.
Yep. And I got one for you, Tommy.
Resistance is futile.
Or variable in this case.
Yeah.
What type of switch is represented by component 3 in figure T2?
Ah, I know this one from my old air conditioner days.
A single pole, single throw.
B, single pole double throw.
C, a double pole, single throw.
D, double pole double throw. Component 3 is going to be a single pole, single throw, and that's because there's only one wire going in, one coming out, and one position for the switch. Well, open and closed.
Mm-hmm.
So that's a single pole, single throw switch.
I'm going to have to agree with you. And everybody else does. Mike says SPST, which is single pole, single throw. The abbreviation for
Getting
it.
fancy.
Yep. It's a Canadian thing.
They're fancy like that.
Yep. There you go. Single pole, single throw. Back from your old air conditioning days.
Hey.
You know, we could use a little air conditioning in here right now, couldn't we?
Yep, pretty much.
It's gotten pretty warm.
Probably won't need any tomorrow when I get to Nebraska.
Probably won't. Well, can you come up with one more question for me?
I bet you we can come up with another. What is component 4 in figure T2? A, variable inductor.
B, a double pole switch.
C, potentiometer.
Or D, a transformer.
Component 4.
All right, component 4.
Oh yeah, I know that one too.
Yep.
I remember that.
So component 4 there looks like 2 inductors, and there's a couple of lines between them. That would symbolize an iron core. And those 2 inductors are actually 2 coils, so 2 coils of wire around a piece of metal. I think that's a transformer, Tommy.
I think you may be onto something.
Yep. And they're saying D over in the chat room, so how can you go wrong with that?
The Transformers. That was a great movie.
Why don't we talk about the diagram for a moment before we go on to any other questions? Okay. And I just happen to have it printed out here. Component 1 here, that is not the symbol for a pig nose. That is symbolizing a plug. I would have thought it was a female receptacle type plug, because I'm used to seeing plugs kind of, electrical plugs kind of drawn like that with the 2 prongs coming out. But that's what that is supposed to be. This right here, I don't know why they drew it like this. It looks like a fuse. But the symbol for a fuse is more like this. You got a wire coming in either side of it, and it's just like a sideways S there.
But if you're, so what is that component?
That's a fuse.
It is a fuse.
Yep. Or at least that's where I would put a fuse in that circuit, so I'm sure that's what they meant there. This, you were talking about single pole, single throw switch. And your logic was, well, there's only one way you can throw that switch and get anything through it, so that's going to make it a single throw. And there's only one set of poles in it, single pole, single throw.
Yeah.
If it had been, if it had had this in there too, then it would have been what kind of switch?
Double pole, double throw.
No.
Double pole, single throw.
Yep. And usually there would be a dotted arrow or dotted line right there between them to indicate that they go together. It's a single switch. A double pole, double throw would have another set of contacts right there. So one way you throw the switch, it connects to that pole. The other way it connects to the other pole. And this, of course, we said was a transformer. And transformer can be used for a couple of different things. This one right here looks like it's the same on the input and output, the way they got it drawn here. It's like it's a 1-to-1 transformer. I don't know if that's what they intended.
Mike VE3MIC says symbol 1 is a neon lamp.
That actually, I think you have to put a dot in there to make it a neon lamp. Oh, that looks like a grounded outlet now.
Oh, forgot about the dot, Mike.
Yeah.
There's no dot. Okay.
Yep. But I'm sure that's not what they meant.
Yeah.
Anyway, a transformer, I'll say a 1-to-1. That's because it looks like it's got the same number of turns on either side. That means whatever voltage you put in it, you're going to get the same voltage on the other side. So it would just be an isolation transformer, more or less. Typically, in most gear, you might see The secondary transformer might have fewer windings on it, so that means it's a step down transformer. You're decreasing the voltage. Or if it had a lot more turns on it, then it would be a step up transformer. It would be increasing the voltage, like for plate voltage on a tube or something where you needed a high voltage.
Okay.
But you can't look at the schematic and just know that that's what they meant. You know that
But this is probably common in an audio circuit, right?
that would well
Just to isolate,
and it would also
ground loop problems and things like that.
it would be common on a service bench. You know, a lot of technicians would use an isolation transformer to plug whatever it is they're working into it, because it gives them it isolates you from the direct AC lines by you know, by having it on a transformer there. The 2 bars here through the middle I mentioned, that means it's an iron core, or it has a core in it. It's not an air core transformer. Okay. And for power, you know, that's what it's going to be. You know, it's a low frequency. They're going to have an iron core in them because it just helps them to work better. At RF frequencies, you may or may not have that in there. You
what about
might have
audio?
a ferrite core. Audio, you would have that iron core in there,
okay,
because that's the lower frequencies, and you know, it's kind of necessary to work at those frequencies. Of course, here we've got a diode. So on this side of the diode, we're going to have positive coming out. So basically what we've got there is just, well, this is going to be a power supply, because here's a capacitor hooked from the side of the diode down to ground. So that's going to filter off any of ripple that, you know, of the AC that may be remaining. The next branch on the circuit here, we've got a resistor, and we've got your LED connected to ground. So that's going to be like the indicator
show
light.
that the power's on.
Yeah, when you turn your switch on, it's going to show the power's on. There's your variable resistor there. That's going to vary the voltage a little bit.
Oh, so it's an adjustable power supply.
It's an adjustable, yep. And there's a Zener diode that the little up and down there on the ends of the line mean that it's a Zener, which begins to conduct at a specific voltage. So, you know, you can have different voltages of Zener diodes. So, you know, this may be,
and
say,
that's a safety. That's a safety device.
Not
What's
really.
that
That's a more like a regulator.
Oh, okay.
So let's say you had 14 volts at this point. You know, after we come through this part of the circuit, we're sitting at 14 volts. You might adjust this to, or let's say it's 18 volts. All right, you might adjust that resistor, so if you measured it right here, you'd have 14. And then with that Zener diode, it would clamp it on down to 12 volts. Anything over the 12 volts would get shorted out to ground.
Okay.
All right, so it's a crude regulated power supply. You probably won't normally see one like this, because there's better ways to do it. Yeah, it is kind of inefficient. So anyway,
cool.
That's what that circuit's about.
And now we know.
And now we know. So now that we've got that behind us, I think we've got.
Need to go to the next one.
We've got some more questions here, and well, I wish I would have got one of these out we could have looked at, but I don't have one handy. I'm going to ask you the question anyway, though.
I figured you were.
What best describes a relay? A, a switch controlled by an electromagnet.
B, a current-controlled amplifier.
C, an optical sensor.
Or D, a pass transistor. Well, a relay is going to be a switch controlled by an electromagnet.
Okay.
And I'm trying to figure out how you could rule out those others. I just don't know how to rule those out.
Other than they're not relays.
Yeah, other than they're not relays. But a relay, I know that is because we use those a lot in the air conditioner days, in the air conditioner stuff too. It's just a magnet, and it basically closes that or opens that a switch like we just showed.
So it could be like your single pole switch, And when you turn on that magnet, it just pulls it down and turns
And
it
either
on.
opens it or closes it, depending on which way it's set up.
I'll agree with that. And everyone in the chat room does. There you go. A switch controlled by an electromagnet. All right, you got a question for me?
I do. Which of the following can be used to display signal strength on a numeric scale? A, potentiometer.
B, a transistor.
C, a meter.
Or D, a relay. Which can be used to display signal strength on a numeric scale? Well, a potentiometer doesn't really display anything. That's a variable resistor. A transistor doesn't really display anything. A meter, well, that kind of displays something, and there's numbers on there most of the time.
Yeah, there's probably about 200 of them in this room here.
Yep. And we just told you what a relay was, so I'm going to say meter.
This in here.
What type of circuit controls the amount of voltage from a power supply? A, a regulator.
B, an oscillator.
C, a filter.
Or D, a phase inverter. We just talked about that on your little diagram.
But the Zener's not one of the answers there.
No, it's not. But it acts as a crude regulator.
Okay.
So I'm going to go with A.
With A.
We've talked about oscillators on this show before, plenty of times.
Yep, that's true. That's true.
We've mentioned filters on here before too, but I don't remember mentioning phase inverters.
Nope.
Fresh out of those.
Yep.
So I'm going with A, regulator.
Well, let's see if you're right. There you go, man. You got it.
Nailed it.
So we didn't get to use the buzzer after all, but hey, that's the way it goes sometimes. Well, I'll tell you what, Tommy,
We passed all of them?
that is all our questions.
No way.
Way. So let's get a quick message from ICOM here, and then we're going to come back and talk about a couple of things, and I'll see who keeps dinging me on text messaging up there.
Okay.
Holiday season is here. Looking for the ideal gift for your favorite contester? The holidays are just around the corner, and ICOM has an array of radios to fill your stockings or place under the tree. Perfect for the contester on the go, try the IC7300. It's a high-performance, innovative HF transceiver with compact design. The real fun starts here. RF direct sampling, 15 discrete bandpass filters, large 4.3-inch color touchscreen, real-time spectrum scope, and SD memory card slot. Push performance to the pinnacle with the IC7600. Following in the footsteps of ICOM's flagship radio, the IC7600 offers intuitive operation and the latest DSP technologies. Digital IF filter, dual DSP, 5.8-inch ultra-wide TFT display, and high-resolution real-time spectrum scope. Raise the bar with the IC7851. Hear what others cannot with this HF 50 MHz transceiver. Reciprocal mixing dynamic range, crystal clear local oscillator design, spectrum scope, dual receivers, digital voice recorder, and more. To learn more about these and all of ICOM's great radios, visit ICOMAmerica.com/amateur today. Well, where we left off is we've gone through all the questions now. And we had an ICOM ad.
We left off at the end. We got a shirt to give
near
away.
the end. Well, we do, but first, last month every month we give away a shirt.
Yeah.
But last month, the winner modeled it for us and sent us this photo here from his ham shack.
He sure did. Awesome.
There's Russ, KB3OPE. Russ sent us in a photo here of his shack. I like the shack, man.
Yeah, it looks nice.
The other operator there looks a bit tired, though.
Yeah.
That could have been his Elmer, I'm not sure. Nice looking shack.
Looking good. You'll be looking good at the Ham Fest.
Yep.
You too could be decked out nice like Russ.
Yeah. See how nice and stylish he looks there? Why wouldn't you want to look the same way?
I think everybody would.
Yep. So let's fix them up, Tommy.
Spike says he didn't enter. He says, pick me, but I didn't enter, though. You need to enter, Spike.
Yep.
There's really no reason not to. Anybody can enter this one, right?
Anybody can enter it, and I don't know, maybe we should tell them how to enter it.
Yeah,
It's
that
pretty
would be
simple
good.
to do.
Send us an email to hamcollege@AmateurLogic.TV. You do not have to be a licensed ham.
Nope.
Just send us your information to that email address, and you'll be in the drawing.
Yep.
And you can win this nice ICOM Ham Crew t-shirt, just like you saw Russ wearing, and the nice ICOM ball cap. I've got one of these too. I'll wear it a pretty good bit.
All right, and the winner is going to be, and boy, I don't know how to pronounce his last name there. George and Tommy, I would like to enter the giveaway for the ICOM t-shirt and cap. Best wishes, Milan Borlakav, into NYU.
Into NYU, congratulations.
Milan, yeah, congratulations.
And, you'll be hearing from ICOM about your size and stuff, and get your shirt and your cap to you.
Yep,
Congratulations.
congratulations.
And you guys go ahead and enter for the shirt and the ball cap. There's no reason not to. Send us an email to that email address you see on the screen right there, hamcollege@AmateurLogic.TV, so you can get yours. Oh, he's in the chat room.
Oh, he is, isn't he?
Awesome.
Yeah.
Congrats.
Congrats. How bad did I butcher your last name? Pretty bad, I bet. And he said the butchering I did on his name is not any worse than the usual butchering. So, thanks. Oh, he's going to send us a picture, Tommy.
I just said that.
You did. I wasn't
Yeah.
paying any attention.
Well, did I not have my volume up? Okay.
Yeah,
that's yours,
maybe.
this one. That'd be cool.
Well, Tommy, I think that'll do it for tonight. We'll be back in a month with another episode of Ham College. It'll be episode 23.
Yeah.
We're getting on down closer toward the end of the technician pool
Yeah.
now. So,
Yeah. Oh, speaking of that, my buddy Billy, that's almost a tongue twister, got his general ticket.
I
He
saw that.
finally
Yeah.
did.
Congratulations, Billy.
Yeah, congrats, man. I kept pushing him and pushing him. He wanted to do it too. He's doing it, but it was something. You know how you kind of mess
Yeah.
with me? Yeah, I kind of gave some of it to somebody
Oh,
else.
you did. Okay.
Yeah, so I can't mess with him now.
Well,
so.
what comes around goes around.
Yeah. Yeah, he's a good guy. I'm glad to see him getting it. So he bought a HF radio and all that stuff a little while back, so now he
Oh,
can
yeah.
talk on it.
Yeah. That's a good reason. We got a friend that bought a IC 7000
Yeah.
a year or two back.
Yeah,
and,
he never did get his general,
he
did
hasn't
he?
got it yet.
Yeah, hope
I
maybe
think
he'll
he's
get it. There's a Hamfest coming
gonna
up
study
soon.
for it
Maybe he'll
again.
go there and get it.
Maybe so. Well, thanks for being here tonight. By the way, go check us out on Facebook. It's facebook.com/AmateurLogic. Also check us out on Google+. You can follow us on Twitter at, where is that address, Tommy?
At Amateur Logic and at Ham College.
Both of them.
Yeah, and if we do any posting, most of the time it'll be on the Amateur Logic account.
Yeah.
But we do announce when we're going to stream. That goes out on both of them. But if we do any random stuff, it usually will be on the Amateur Logic one.
Yeah.
And if you want some Amateur Logic swag, where can they go? Or Ham College swag, where can they go for that?
AmateurLogic.spreadshirt.com.
Yeah, that's where they can go. So if you want to get any of the swag, go check us out there.
Yep.
Make great Christmas gifts for your ham friends.
They will. And for those budding students,
73, everybody. We'll see you guys next month on Ham College, and then about 2 weeks on Amateur Logic.
cool. All right. See y'all then. getting all
Haven't
these
we wore
questions
this
from.
circuit out yet?
No, we hadn't.
Okay, well, let's talk about it then.
Okay.
Oh, sorry.
Yeah, that's why. What best describes a relay? A huh? Oh, I see what you're talking about. Yeah, I kind of give it away, didn't I? I know I'm not going to get to use a buzzer this time.